cloud is a public Wi-Fi access provider. We are leading independent European Wi-Fi operator. We have more than 22,000 access points across Europe. In UK, we have the focus on retail chains such as Pret, Pizza Express, Pret a Manger, Cafe Nero, where we have Wi-Fi hotspot coverage. In some of these venues, we also take care of the back office. The cloud offers a variety of services. For end users, it's mostly free public access Wi-Fi. For venues, it's fully managed service. And for mobile network operators, 3G offload. Mobile data offload is a key cornerstone of the cloud's portfolio. We offer offload methods for several carriers. The ease of offloading a 3G in a similar manner than you would be offloading the traffic from a 3G network to another 3G network is coming to Wi-Fi. What differentiates the cloud and BSkyB especially from the other providers in the market is that we own a lot of content, video content such like Premier League football. We do want to provide that to our users in all of our locations. We have an invested interest to be able to offload a lot of data, our own data, video. Streaming video over Wi-Fi has always been the most difficult part of the equation because of the amount of data just skyrockets. We can see that the users use video more and more. 30% of the data is video today. It will be 60% by the end of next year. And the Wi-Fi by its very nature is well suited to deliver video for a single user or maybe 3 users. But when you introduce the density of 100 users per hotspot, you're going to have to do something very clever with the technology. With our legacy kit, we found the user density to be a problem. Back in the day, the users used laptops. They were static, they didn't move anywhere, and the user density was lower. When the user density went up, the more users authenticating, disauthenticating from the access points started to topple over. We needed to remotely reboot them, or worse yet, ask the customers, call the venues to reboot the modems. Wi-Fi today is highly congested. The 2.4 gig is very congested in hotspot locations. It's very common to see 10 other access points in the location. We need to be able to manage that automatically. The users are no longer using laptops, but smartphones. There's a lot more users by the 100-fold. There's also a lot more interference on the 2.4 gig frequency. We've seen in excess of 15,000 access points within the square mile that are not ours. It gives us an interference factor that we could not mitigate with the older deployment. So we needed something that automatically finds clean air and gives us the ability to mesh within our indoor venues. If the access points can automatically find clean air, we can keep the user experience consistent and the hotspots up to speed. We tested the Ruckus outdoor access points. We put them on the streets of London, where the RF is quite messy. We wanted to see the signal reach both within the streets as well as indoors to enable indoor-outdoor meshing from the outdoor network into the indoor venues. That gave us the form factor, the nice price, and it also came in black, which was crucial for this deployment. Traffic black. We wanted, from the new Wi-Fi solution, full compliance above and beyond the 802.11n standard. That includes dual radios, includes meshing, indoor-outdoor, and automatic RF management, together with a very solid user management centrally. We have been able to take the bottleneck away from the radio interface with the dual-band outdoor 802.11n access points, largely due to the fact that they can mitigate the interference. We've done extensive research on this, also done a lot of piloting, not just in the labs, but in the streets of London. Waterloo Station was a pilot site for us. The ability to capture the users when they get out of the train and hold them onto the network all the way through the station as they exit was crucial to be able to offload as much data as possible. Results were really good. The Ruckus access points were able to blend into the background, so the form factor was okay. We were able to use existing locations and cabling, so we just refreshed the kit. We immediately got 10 times more users into the network using more than 10 times the bandwidth that we previously were using. Between the products that we tested, we found that there weren't a whole lot of options in that market. The differences were really made on how they mitigate the interference. The Ruckus access point is good in utilizing fully the available RF in the venue. We know we have a limited amount of channels available, so we cannot put more access points in. So we have to make the best we can from the single access point, and that's why we want to use a quality radio. One of the things we find we don't have to do anymore is to worry about the access point. It's a plug-and-play solution. The Ruckus antenna is different from anything else. It has dual polarity, it has beamforming, it has a very clever software behind it as well. All of those are key to be able to serve multiple clients with a lot of bandwidth. The cloud is very concerned about the user experience in a congested hotspot environment. We find that it's all about the antenna to be able to maintain a good user experience. Under heavy loads, when users need increasing amounts of data, it is all about the antenna, not just the dual polarity of it, not just the beamforming, not just the interference mitigation, but the combination of them. I think Ruckus is a good product suite, so getting some things right at the very early in the game, like the antenna, it's all about the antenna. I think the antenna is genius, that's what I think.